Potatoes here. This video will cover Chapter 1, Sequences and Series, Part 1.1, which is Arithmetic Sequences. Let's talk about what a sequence is. A sequence is an ordered list of objects or numbers that follow a definite pattern. So the parts of the sequence are called the terms. So because they are terms, we use T for term. So this is T1, which is the first term, T2, which is the second term, T3, which is the third term. But the way that we say these term numbers is T sub 1 and T sub 2, etc., because they are subscript, okay? So this Tn, or T sub n, is the nth term, which is the term in general or the last term in the sequence. So if I say last term, that implies that the sequence is n. So in fact, there are two types of sequences that we can talk about. One is finite sequences. Those are sequences that have an end point. They stop. So since they stop, you can count the number of terms. So here's an example: 1, 5, 9, 13, a whole bunch, and then 97. So there's an end point. The other type that we can deal with is infinite sequence. Those have no end point, so you can't count the number of terms because they go on forever and ever. So we'll be dealing with those in 1.5. In this section, we're dealing with an arithmetic sequence, which is a finite ending sequence in which terms have a common difference. That means they are equally spaced apart. So because they are equally spaced apart, they go up slow and steady. They have linear growth. So it's kind of like a line. So you have the number of terms versus the term number, and it's going up a step at a time. So the arithmetic sequences, when they're graphed, are a linear graph. So let's look at an example here. I want to know if this is an arithmetic sequence. So I start at 5, that's my first term, and I go to 8. Well, I do that by adding 3. And then I go to 11. Well, I can take 8 and add on 3 to get 11, but I always want to start compared to my first term. So starting at 5, I can add 3 and add another 3 to get to 11. And then 14. So I start at 5, I add 3 to get to 8, 3 to get to 11, and 3 more to get to 14. So we always compare everything in a sequence to our first term. So starting at 5, I can add 3, add 3, add 3, and add one more 3 to get to 17. So what's happening is I'm adding an extra 3 every single time. So here's what I'm doing. I'm adding one more 3 to the first term to get the next term. So this is my first term. So my second term is starting with my first term, I'm adding 1 3. And then starting with my first term, I'm adding 2 3s, 3 3s, and 4 3s. Well, the number of 3s that I add is always 1 less than the term number. So see here how I add 1 3 and the term number was 2. Here I add 2 3s and the term number was 3. I add 3 3s because the term number is 4, 4 3s because the term number is 5. So let's use that pattern to come up with the 71st term. I would not want to do plus 3 plus 3 plus 3 to get to the 71st term. So we're going to use our pattern of starting with the first term and adding on multiples of 3. How many multiples of 3? 1 less than the term number. So this is 71, 1 less would be 70. So that means that my 71st term would be 5 plus 210, or 215. So let's use this idea of patterns to come up with the general term. In general, how can we come up with an arithmetic sequence term? So if I start with my first term, I'm going to add on my common difference to get my second term. But I don't know what my difference is, so I'm going to keep it in general. So first term plus my difference is my second term. If I start with my first term and add on difference and another difference, or 2 differences, I get my third term. My fourth term is the first term plus 3 differences. My fifth term is the first term plus 4 differences. So what my tip here is, again, the number of differences added to the first term is 1 less than the term number. So let's come up with the pattern in general. So for the nth term, T sub n, I take my first term and I add on multiples of the difference. How many multiples? One less than the term number. So if the term number is n, one less would be n minus 1. And this is the general term of an arithmetic sequence. So let's look at it piece by piece. So t sub 1 is your first term. N is the number of terms. D is your common difference. So you can take any term and subtract the term before it. So second term minus the first term, for example. And T sub n is your general or last term. Now, my big tip for you here is, this is a mistake students sometimes make, is they confuse n and T sub n. So here's how I remember it. N is for number of terms, so n with n. T sub n is for the general term. So n with n, number of terms, t with t, it's a term. So then we won't confuse those two together. Okay, let's try an example here. So we have a community events leader paid $12 for 1 hour of work, 19 for 2 hours, 26 for 3 hours, and so on. We want to write an equation for the general term to determine the amount of pay for any hours worked. And when I say any hours, that means just leave n as n. So for a general term, we just want to leave n as n. So we're going to find out what my first term is, my difference, and we're going to simplify. So the very first term in my sequence is this $12 for 1 hour of work. So we do 12 hours, and then we do 19 hours, and then 26. So 12 to 19, it looks like I'm going plus 7. 19 plus 7 is 26, yes. So my common difference is 7. So let's put that all together. So first term plus n minus 1 differences. So I want to simplify this, so I'll distribute that in. So my nth term is 12 plus 7n minus 1. So that's just 7n, and then 12 take away 7 is 5. So this is my general term, 7n plus 5. So let's use that to answer a couple questions. So first question says, what will the rate of pay be for 6 hours of work? So 6 hours is an n value. So this is saying if I know n is 6, what is t sub n? So t sub 6, so the n's are the same, these n's match, 7 times 6 plus 5. So 7 times 6, 42, plus 5. That means that my sixth term is 47, meaning I will make $47 for 6 hours of work. Okay, in this one it says, how many hours would you work to make this amount of money? So this would be your nth term, and we want to know how many hours. That means we're solving for n. So my nth term, 6450, is equal to 7n plus 5. So first thing that I'm going to do is subtract 5 from both sides. And then I have 6450 take away 5, that's 5950 equals 7n. So I would just divide both sides by 7, and I would get 8.5 equals n. So that means I would have to work 8.5 hours to make $64.50. So once you have the formula, it's just a matter of substituting in the numbers and solving. Let's try this one. So in 1955, the oxen population was about 9,250. Suppose in subsequent years the growth rate increases by about 1,650 per year. How many years would it take the oxen population to reach 100,000? So there's only one unknown that I'm allowed. And when I see the question, how many years, that tells me n is the unknown, which must mean I know everything else. So I started with 9,250. I want to end with 100,000. And my difference is I'm going up by, increasing by about 1,650 every year. So now it's just a matter of substituting it into our formula. And then we just solve for our n value. So since I want to get n by itself, I want to get this n minus 1 by itself first, and then go from there. So I'll start by subtracting 9,250 from both sides. So I do 100,000, take away 9,250, and I get 90,750 equals n minus 1 times 1650. So resist the urge to distribute this inside the brackets because that just adds an extra step. Since I want to get n by itself, I'm just going to divide both sides by 1,650 to get the brackets by themselves first. So I end up here with 55 equals n minus 1, and then just simply add 1 to both sides to get 56. So answer with units, it would take 56 years to reach 100,000. Okay, this next question here, we have the top 6 rows of the cereal box display shown. So we don't know what the first term is. Somewhere down here is the floor, and we know that this is the top 6 rows. So there are 16 boxes in the 3rd row from the bottom. We want to use this information to figure out how many boxes are in the bottom row and how many rows is this display altogether. So I know that the 3rd row has 16 boxes. I don't know how many are in the 2nd row or in the 1st row, which is the floor. So let's look at the display here. If I look at any row and compare it to the next row, that's going to give me a common difference. So for example, if I look at this row, 1, 2, 3, 4 boxes, and then 2 boxes. This row here has 1, 2, 3, 4, 5, 6 boxes. So it looks like as I go up to the nth row, this is the nth row, it looks like I'm going down by 1 each time. So I know my difference is down by 2 each time. 6 subtract 2 is 4, subtract 2 is 2. Okay, my end row is 2. Now I'm only allowed 1 unknown, so I need to be able to figure out what my first row is. So if going from the floor up, I'm going down by 2, I need to work backwards to figure out what my first term is. So if I'm going down 2, going up, going down backwards, I'm going to add 2. So to go from 18 to 16, I must have gone down by 2. So I added 2 to go backwards, add another 2, and I get 20. So my first row must be 20. So 20 take away 2 is 18. Looks like it works. Take away 2 is 16. So now I can solve for the thing I don't know. So my nth row, my t sub n, my last term is 2, equals to my first term plus n minus 1 differences, and I don't know the differences. So very similar to the last question. So I will subtract 20 from both sides. So negative 18 equals n minus 1 times negative 2. Again, we want to get n by itself, resist that urge of distributing the negative 2 inside the brackets. I get 9 equals n minus 1, and then simply add 1 to both sides, which tells me there must be 10 rows in the entire display. Okay, let's try this one here. I want to solve for x. If x minus 2 and then 2 and then 4x plus 1 is an arithmetic sequence. Okay, so I don't know what x is. So let's substitute in what we do know. So we do know that our nth term, t sub n, our last term, is 4x plus 1. I know my first term is x minus 2. I know that there are 3 terms. And then the difference is, well, I can take any term and subtract the term before it. So I can go, for example, 2 take away x minus 2. So that would be 2 take away x, take away a negative 2 is a positive 2, which is 4 minus x. So substituting this all in, I can go 4x plus 1 t sub n equals the first term, x minus 2, plus n minus 1, 3 minus 1, differences, and the differences are 4 minus x. So I can definitely solve this equation, okay, but there's actually an easier way of doing this. So there is a better way just ahead. This way would totally work, but I just want to show you another way of doing it. So let's continue. You can continue solving this one here on your own if you like this way of doing it, but I want to show you, in my opinion, what's a better way of doing it. And this is focusing on the difference. If you truly understand what a difference means, there is an easier way of doing this question. So what the difference is it's any term subtract the term before it. So for example, the second term, subtract the first term. Or I can say the third term, subtract the second. Or the fourth, subtract the third. And I could just keep on going. Okay, so let's take this idea. So we have x minus 2, and then 2, and then 4x plus 1. So those are 3 terms. So I can take the third difference, take away the second difference. That's the difference. And the second term, take away the first term, is also the difference. And I can put these all together just to solve for the difference. So second term is 2. Take away first term, x minus 2, would be the same, because it's the difference, as the third term, 4x plus 1, subtract the second term, which is 2. So I have 2 take away x, take away a negative 2, is the same as 4x plus 1 take away 2. So tidying it up, 4 minus x will be the same as 4x minus 1. So I think this is a little bit easier than the other way of doing it. I now have a linear equation which I'm going to solve by getting my x's on one side and my number on the other. And then you see 5x equals 5, divide both sides by 5, and you get a solution that x equals 1. So this method I think is a little bit easier, but either way is fine. Okay, so that's the end of our lesson. I thought this was a really cute joke. You know how moms, when kids are fighting, they always say that they're going to count to 3. Well, this is a math mom, and she says that you need to stop fighting in n plus 1, n plus 2, arithmetic sequence, get it? So you guys can do practice questions 1 to 4, which are in my notes, and then when you're done, you can move on to the textbook questions. So I hope this video helped, and I look forward to seeing you for the next one.